Algebra 2. We've got lesson 9, multiplying radicals with the distributive property and dividing radicals with rationalizing. This is a big one. This is a big one today. Okay. This would be one that you're going to learn, or you're going to continually mess up questions over and over again. So let's learn it. All right. Simplifying radical expressions, we can have a radical in simplest form if we can factor out, radicals and simplify them. If we can do that, then it's not simplified. So make sure that we factor them all out. No radicand can contain fractions, and no radicals appear in the denominator of a fraction. So to meet the last two conditions, we have to rationalize the denominator by multiplying the expression by a 1. This is an appropriate form of 1. I want to emphasize that we are multiplying by a value of 1, which does not change the value. It's just going to change what it looks like. Okay. So, I'm so sorry. Start out, we're just going to go ahead and multiply. This was in our last section. And actually, let's talk about conjugates real fast. Conjugates would be two binomials, A plus B and A minus B. The first term of both binomials exactly the same. The second term, both binomials exactly the same. We just have a different sign in the middle. So those are called conjugates. And when we multiply those together, we will always get a difference of squares. So these are multiplying conjugates. Will always give us a difference of squares for the final answer. I'm not going to do the shortcut quite yet, but if you know that this is true, you will have a shortcut. Take you less time to do your math. I'm just going to go ahead and multiply this first one all the way, and then the second one I'll use the shortcut. So we can multiply by distributive property, or you can make a grid. I know on the last video I did the grid, so this one I'll use the distributive property. So 8 times 8 is 64. 8 times 5 square root x is 40 square root x. And then negative 5 square root of x times 80 is minus 40 square root x. And then negative 5 square root of x multiplied by positive 5 square root of x is negative 25x. Now we look in the middle and we combine our like terms. They have the same radical, the same exponent, or same variable, same radical. But one is plus 40 and one is minus 40, so these cancel out. And we get 64 minus 25x. So that follows that pattern of a squared minus b squared for the difference of squares. So this one, if I want to take that shortcut, and you don't have to do the shortcut. If you don't understand it, that's okay. Just use the grid, multiply it out. If you want to take the shortcut, we will be looking at 4. Our outside and our inside will cancel out. And then our last will be minus 3, which is 1. Those are conjugates. Oops. Let's see. Next one is just distributing. We can distribute and we can multiply radicals that have the same root. So both of these are cube roots. So I will have 3 times the cube root of 2 times 4 plus 5 cube root of 2. So make sure that I distribute it to both terms. Now, this cube root of 2 times 4, you can write it as cube root of 8, or you could write it as cube root of 2 to the 3rd, because 4 is 2 times 2, so there's 3 2's under there. Either way, you're going to get cube root of 8 or cube root of 2 to the 3rd is just going to be 2. So my answer to this would be 6 plus 5 cube root 2. Cannot add those together because they are not like radicals. Here we've got 2 questions for the price of 1. We've got 2 questions. Let's see. Cube root of 2 times square root of 2. These are not the same index numbers. So I could change it to 2 to the 1/3 multiplied by 2 to the 1/2. So I can use my multiplying like bases rule, which says you can add the exponents. In order to add exponents, well, these are fractions, so I would need common denominator, which is going to be a 6. So this one I'd do multiply by 2 over 2. This one I'd multiply by 3 over 3. Now we get 2 to the 2 6's plus 3 6's, which is 2 to the 5 over 6. And we can rewrite that as the 6th root of 2 to the 5th, or the 6th root of 32. All right, so that's one of them. The other one, so we've got cube root and we've got square root. So again, these are different roots. So I'll go ahead and change them both into rational exponents, 2 to the 1/3, multiplied by 3 to the 1/2. And now we do not have like bases. So we can't do the step that we did here. We can't do that one. So there's really nothing I can do to this one. Nope, that's not true. I lied. There is something I can do. It's just going to be different. So what I can do is, how about change them so they have the same denominator. So that means I'm going to have a 6. So this will be times 2 over 2. This will be times 3 over 3. And we'll have 2 to, oopsies, what did I do there? We'll have 2 to the 2 over 6 multiplied by 3 to the 3 over 6. And then we notice they both have the 6 for the denominator. So I'm going to say that this is 2 squared times 3 to the 3rd. And that entire thing is to the 1/6 power. So I kind of factored out the exponent. I'm going backwards in my exponent rules. And from here, I could say that's 4 times 27 to the 1/6 power, which I don't know what 4 times 27 is. 4 times 30 minus 4 times 3, 120 minus 12. So 108. So that'd be the 6th root of 108. You can see that we did the work very different. I mean, not totally different, just sort of different for both of these. Really around this step is where it got the most different. All right. When we divide or multiply, remember we can divide or multiply parts that are like. So in this example here, it's just written out. I'm going to work through it, but it's written out for you. I could reduce the 4 over 2 and get 2. And then I could divide these, since they're both square roots, and get square root of 2. Okay, rationalizing the denominator. I'm going to go through all of what it says here. But if you need to refer back to it, it's all written down. But I'm going to go through that while we do our questions. So right now I have a square root of a fraction, and that is not reduced. So what I'm going to do is I'm going to split apart this square root to be square root of 1 over square root of 2. That helps me with the top. That becomes 1. Square root of 1 is 1. But square root of 2 on the bottom, you can't do anything with, and we are not allowed to leave this with a radical in the denominator. No radical in the denominator. Okay. So for this one, because we have a radical in the denominator, we are going to multiply, just like finding a common denominator, we're going to multiply by a value of 1. It's going to be the same thing on the top and the bottom. And after we multiply by that value of 1, we are going to get the square root of something squared. Let me put that square in a different place. Remember, we can put the power on the inside or the power on the outside. So when I look at the number that is sitting here, and it's a 2, then when I'm done, I want to multiply by something that gives me the square root of 2 squared on the bottom. So we say, what times square root of 2 gives me square root of 2 squared? Well, that would have to be a second square root of 2. That's how I square it and multiply by itself. So if I do it on the bottom, I have to do it on top as well. Multiply straight across, and I get 1 times square root 2, which is square root 2. On the bottom, square root of 2 times square root of 2, which is square root of 2 squared. So again, this is multiplied by a value of 1. That makes the root and power match. Makes the root and the power match in that answer. Okay, so now I'm going to simplify the denominator, and these cancel out. The square root of squared cancel out, and we get 2. So square root of 2 over 2 is our simplified version of square root of 1/2. That seems like a lot of steps, but I promise it gets much easier as you do it more often. So here's our next one. We've got a 3 on top, and we've got a square root of 5 on the bottom. And square root of 5 cannot be simplified. So I'm going to multiply by a value of 1. And when I'm done, I want the square root of 5 squared. That's what I want when I'm done. So I need to multiply by a square root of 5. But I have to do that on the bottom, the top, and the bottom. Change the color here real fast. Just writing the same thing. I just wanted it in a different color. Okay, so if I multiply square root of 5 times square root of 5, I get square root of 5 squared. On the top, 3 times square root 5. Now these will cancel, the square root and the squared. So we get 3 square root 5 over 5. Now the 5s cannot cancel because one is on the inside of a radical, one is not. So this would be our simplified answer. Question C is a cube root. A cube root. So we're thinking cubes here. First of all, before I even get started, 3 over 6 can reduce. So I'm going to have the cube root of 1 over 2. So this is a lot like question A, only it's cube root. So how does that change it? Well, first of all, I'm going to go ahead and do the cube root of 1 over the cube root of 2, and that will give me 1 over cube root of 2. Now, cube root of 2 is not, it is a radical, so this is not simplified. We have a radical in the denominator, not simplified. So I am going to multiply by a value of 1. And that value of 1 has to be a cube root of some sort, because I can only multiply cube roots times cube roots. And when I'm done, I need for the answer to be the cube root. Let me make that a little bit better writing. It's got to be the cube root. And since I'm starting with a 2, it's going to be a 2 to the third when I'm done. That's what I need to have when I'm done. So I have a 2 to the first. When I'm done, I need a 2 to the third. So what I'm missing is 2 more 2s, 2 to the second. If I do that on the top and the bottom, I'm multiplying by multiplying by a value of 1. They're exactly the same. So this does not change the value. It's just going to change the appearance. So we go straight across to the first, 2 more 2s. We get 2 to the third, and then the third root of that. On top, 1 times cube root of 2 to the third is cube root of 2 to the third. So now the cube root and the cubed cancel each other out. On the top, I made a mistake 2 times in a row. Same mistake. On the top, it's just squared. Sorry. Oops. There we go. On the top, they do not cancel because 1 is squared and 1 is cubed. So I'm just going to simplify my top, and I'm going to get the cube root of 4, and the denominator, the bottom, is just 2. These cannot cancel because 1 is under a cube root and the other is not. All right, question D. So I've got the cube root of 3 over 16. Now those do not simplify. So I'm going to break them apart. I'm going to do the cube root of 3 over the cube root of 16. Now in my denominator, 16 does have a perfect cube in it. 8 multiplied by cube root of 2 is the cube root of 16, and the cube root of 8 is a perfect cube. I'm just going to go down here. So I have the cube root of 3 over, this becomes 2 cube root 2. So after simplifying this, I still have a radical in the denominator. So what I'm going to do is I'm going to multiply by a value of 1, and it has to be a cube root because that is the radical that we are dealing with right now. It has to be a cube root. After I multiply in my denominator, the 2 on the outside does not have to change at all. But the inside does. The inside has to become 2 to the third. Right now, it's just 2 to the first. So the 2 that is on the outside can just stay the same. On the inside, if I have 2 to the first, I need 2 more 2s to make 2 to the third. So on top, that tells me that I need to multiply cube root of 3 times cube root of, this is 4, and I get the cube root of 12. On the bottom, this cube and the cube root, those two things cancel. And so we get the cube root of 12 over, so here's that first 2 that just kind of, let me highlight that so it really stands out. This 2, this 2, this 2, they're all the same 2. They keep, just going to the next step. But the other one, we've got another 2 down there from crossing out the cube root and the cube. So we finally get cube root of 12 over 4. All right, next one is 4th root of 3x over 2. Those don't reduce, so I'm going to go ahead and write the 4th root of 3x over the 4th root of 2. And I have a radical in the denominator, which means I have to rationalize. Since it is a 4th root, I will think about multiplying by 4th roots. And when I'm done multiplying by the 4th roots on the denominator, I should have the 4th root of 2 to the 4th. That's what I'm going to have when I'm done. So let's see, if this is to the first, then I need 3 more 2's to make 4 of them. I'm going to do that on the top and the bottom. So up here, we're going to have 3x multiplied by 2 to the 3rd is 8. 4th root and 4th power cancel. So we get the 4th root of 24x over 2. And that 2 cannot simplify with anything inside of the radical. So that's all we could do. All right, this next one, 5th root, they're both 5th root. So just looking at this one, I know that 8 is a power of 2. It's 2 to the 3rd. So I'm actually going to rewrite this as 2 to the 3rd, and then that's to the 3rd. This does not have to be the only way you do this one, but I always think it's easier to make the powers prime powers rather than try to work with bigger numbers. So if I do that, now I have the 5th root of 2 to the 9. And I can simplify that. So on top, I still have the 5th root of 7, but on the bottom, now I have the 5th root of 2 to the 5th multiplied by the 5th root of 2 to the 4th. So I've got 9 total 2's down there. So I can pull out a full power. And I'm going to come down here to finish it. On top now I have the 5th root of 7. On the bottom, this becomes 2. And I've got the 5th root of 2 to the 4th. Now to finish this, I still have a radical in the denominator, and I cannot cancel those powers out. So I am going to have to multiply by a power of 1. I'm sorry, a value of 1. And it's going to be 5th root for both. And after we multiply in the denominator, I'm going to have that 2 that's out front to start, that one. And then I'm going to have the 5th root of 2 to the 5th. That's what I'm going to do. So if I got 4 of them, then I just need 1 more to complete the 5th. So on top, I'm just doing to the multiplying by 2 under the radical. So on top, I get 5th root, sorry, of 14. So if those cancel, then underneath I have this 2 multiplied by another 2. So we get the 5th root of 14 over 4. All right, question G. So this is cube root. So I'll go ahead and do cube root of 3x to the 3rd over cube root of 8y to the 3rd. On top, the cube root of 3 multiplied by the cube root of x to the 3rd On the bottom, I get the cube root of 8 multiplied by the cube root of y to the third. Well, that cancels. That cancels. 8 is the same thing as third root of 2 to the 3. So that cancels. We get 3x over, nope, we don't. Just kidding. Let's start that again. We get x, and then the third root of 3. And then on the bottom, we get 2y. This is done because I don't have a root. I don't have a radical in my denominator. We do square root of 4a over square root of 3b. Before I go any further, I notice the square root of 4 can become 2. So 2 square root a over square root 3b. Okay, so in the denominator, I am going to have to rationalize. I'm going to have to multiply by a value of 1. They're both going to be square roots. When I'm finished, I need the square root of something squared. Now look here, there is a 3 and a b. So I'm going to need 3 squared and b squared. So to get 3 squared and b squared, I will need to multiply by 3 and b. So on top we have 2 square root 3ab. On the bottom, the square root cancels those squares. And we will have 2 square root 3ab over 3b. All right. Cube root of 3y over the cube root of 4x squared. I'm going to change this 4 into a power. So I have the cube root of 2 squared x squared. Now, I'm going to multiply by a value of 1. It's going to be cube root. And then after I multiply, I want to have in the denominator the cube root of 2 to the third x to the third. That's what I want when I'm done. So when I look here and I see 2 squared, well, I need another 2. When I see x squared, I need another x. So that's how I'm going to get 3 of them down there. So my numerator, I'll go ahead and multiply that together. I get the cube root of 6xy. In my denominator, these will cancel, and I will get 2x. Okay, the last section would be just a little bit about conjugates. We went over that just a little bit ago. When we multiply conjugates, we have a binomial times another binomial. Okay, these are binomials. They have the exact same first term, the exact same last term, but one is plus and one is minus. And when we do that, we multiply all these out, the middle 2 terms will cancel. So it's just like multiplying a squared minus b squared. So if we did 2 times 2, that would give us 4. And if we did square root of 3 times square root of 3, or negative square root 3, that would give us minus square root 3. And then from there, there's no more square roots, and we have an answer of 1. So conjugates are very helpful because we can cancel out square roots. So we will use conjugates when we are dividing a binomial that has a radical in it. So here's my binomial down here. When we go to multiply by a value of 1, that will cancel out the square root in the denominator. We're going to multiply by the conjugate. Multiply by the conjugate of the denominator. Conjugate of the denominator. So I'm going to be multiplying by 5 minus square root 3 over 5 minus square root 3. That is a conjugate. Same first term, same last term, different signs. Now, binomials go in parentheses. This is also a binomial. So just be careful when you multiply these that you keep them in parentheses. On top, 1 times 5 minus square root 3 is 5 minus square root 3. On the bottom, you could make a grid, or you can draw those arrows and multiply. But since they are conjugates, we will get 25 minus 3. We will get the squared of 5 and 5. We will get squared square root 3 and negative square root 3. So we have 5 minus square root 3 over 22. And in this situation, this is kind of like what you get with what's called quadratic formula. You want to make sure that the radical is simplified all the way. We cannot have a negative in the denominator, and there isn't anything I can factor out and cancel, but there could be. So we'll look out for it. All right, so here's another example. I'm going to multiply by the conjugate of the denominator on the top and the bottom. So 1 plus square root of 2, 1 plus square root 2. So those are exactly the same because we're multiplying by a value of 1, but the denominators have different signs. So you can make a grid, or you can distribute, or you can learn the rule that if you multiply conjugates, you're really multiplying the first term, the outside and inside cancel, and we multiply minus square root of 2 times square root of 2, so 2. On top, I am distributing that, so 5 plus 5 square root 2. So I'm going to simplify that, and I get 5 plus 5 square root 2 over negative 1. So we can't leave a negative 1 in the denominator, so I will go ahead and multiply negative 1 over negative 1. That is another value of 1 that I need to distribute. And so I'll get negative 5 minus 5 square root 2 over 1. So I'm not even going to write it because it's over 1. Okay. We've got a radical as part of a binomial in the denominator. That's a binomial. This is a binomial. But what matters is what's in the denominator. So we're going to multiply by the conjugate of the denominator. 3 square root 3 plus 3. Same thing on top. 3 square root 3 plus 3. So that's what I'm multiplying by, a value of 1. Now on top, I am going to have to maybe make a grid or use your distributive FOIL property, however you want to do it. I'm going to zoom in so I can write easier in here. It was 2 square root 3, I already forgot, minus 3. And then 3 square root 3 plus 3. So that'll give me 6 times 3, which is 18. That a little bit bigger. 6 times 3, which is 18. There we go. And then this one will be negative 9 square root 3. Down here is going to be 6 square root 3, and this will be minus 9. So my new numerator is going to be, what is this? 18 minus 9 is 9. And then minus 3 square root 3. And then my denominator, we've got 3 square root 3 squared. So it'll be 9 times 3, so 27 minus, and then 3 times 3 is 9. 9 minus 3 square root 3 over 18. Now, square root of 3 is simplified all the way. I have a positive, but I also have a number that can factor out of the numerator and can cancel with a number factored out of the denominator. So the number I'm going to factor out is 3. When I take out that 3, I have left over 3 minus square root 3. In my denominator, I'm also going to take out a 3. And I'm left with 6. If you factor out the same number, you can cancel it. It has to be factored first. So now I have 3 minus square root 3 over 6. These will not subtract. One is the square root, one is not. The 6 will not divide the square root 3. So this right here is a completely great way to write your answer. You could do this. You could separate the terms, but I like this answer. It's just a lot cleaner and simpler. So our last example. Okay. So we're going to multiply by the conjugate of the denominator, which is going to be square root 2 minus square root x. Got to put that in parentheses. So on top, I will distribute 5 square root 2 minus 5 square root x. In the denominator, I can use my shortcut, which says difference of squares. So we'll square the square root 2, which is 2. And then we'll do minus, and we'll square root these square root of x's, which is x. And there's nothing else that I could do to this question. I mean, possibly you could write it like 5 square root of 2 minus square root of x over 2 minus x, but this, I think, is just a simpler way of writing it. So that's all I could do to that one. All right, so you've got a worksheet for this stuff. Make sure if you have any questions at all, you contact me and get those questions answered. This is a pretty important section. Have a wonderful day.